with time. So del k by del t is equal to 0, which implies k is a constant of motion, which implies t cannot occur in k explicitly. Since it is a conserved quantity and del k by del t is 0, k does not contain t. So hence our generating function f does not contain t because we have k is equal to h plus del f by del t. So, okay. So t absent means t is also absent from this term. So if t is absent, then del f by del t will be 0. So k is equal to h. For a conservative system, t is generally absent in the Lagrangian and Hamiltonian. Okay. It is absent means k is equal to h. But Qj is cyclic. Q cyclic means Qj does not appear in K. So K is only function of Pj. But we found Pj are constants alpha j. So now K is a function of coordinates alpha 1, alpha 2, alpha n, which are constants. Again, from first Hamilton equation, we know that Qj dot, capital Qj dot is equal to del K by del Pj. Capital Qj dot is equal to del K by del Pj, del K by del alpha j, and which is equal to, let's say, omega j. Since we take derivative, we found some quantity, we call it omega j. They are the function of alpha j only. And hence all the constant in are constant in time. So what is capital Qj? It is Qj dot means d Qj by dt. D capital Qj by dt is equal to omega j. So what is Qj? Qj will be how much? Hello? If d Qj by dt is equal to omega j, then what is Qj? How you get Qj?
Omega t, sir.
Take
Omega
integration
Omega
omega
Wj.
t. So it will be omega t. Omega t plus a constant. That's it, beta j.
Wj.
So we found Qj plus beta j. Beta j are constant of integration, depends on the initial condition. If initial condition given integration, then it will depend on that. Okay. This is the general formalism. Now I will apply it to two cases. First one is your harmonic oscillator. We know it's the simplest example, harmonic oscillator. Harmonic oscillator means actually a mass spring system. A mass is attached to a spring. You know, this is your harmonic oscillator. A mass is attached to a spring. When you slightly stretch this spring, then mass executes simple harmonic motion. This is known as a simple harmonic oscillator. For simple harmonic oscillator, your force is proportional to negative opposition coordinate minus x or minus q. That means potential energy will how much? You know, F is equal to
Yes.
negative gradient of potential minus del V by del Q. So what is V? If F is equal to minus Q, then V is equal to
Again, sir.
whose derivative is equal to Q?
FQ.
No. No, it is if half
Again, sir.
Q square. They are proportional, no? No. So half Q square, or if you take constant half K Q, its derivative is how much? Half Q square derivative is 2Q by 2, 2 to cancel Q. Isn't it? So it will be half. So V potential energy is half KQ. Half KQ square. So total Lagrangian will be kinetic energy half mq dot square minus half kq square. K is spring constant, but it is related to the mass of m omega square. You know it. So K is equal to m omega square. So you can like Lagrangian is equal to half mq dot square minus m omega square q square. Then what is Hamiltonian? We know formula Hamiltonian is sum dot p is qj dot minus l. But here only one coordinate, one dimension. So one coordinate means we write p q dot minus l. Okay, so but P is equal to del L by del Q dot Hamiltonian equation. So Lagrangian, from Lagrangian we know that P is equal to del L by del Q dot. If you take del L by del Q dot, it will be M Q dot. So that Q dot is equal to P by M. because Hamiltonian is a function of QP only. So all Q dot should be removed or replaced by Q and P. Okay. So Q dot is P by M. So now put a Q in place of Q dot P by M. So it will be P into P by M minus L minus half M Q dot square minus minus plus half K Q square or M omega square Q square. Then replacing Q dot by P by M, we got this half P square by 2 minus half P square half Q square, or it will be half P square by M plus half KQ square. Okay, so that Hamiltonian is equal to P square by 2M plus you replace K by M, it will be half M omega square Q square. This is the Hamiltonian for harmonic oscillator. Now we use equation of motion or Hamilton's canonical equation of motion. We know that P dot is equal to minus del H by del Q. If taken derivative, we found minus del H by del Q is how much? There is no Q. On this term we take derivative. Q square 2Q, 2 cancel, M omega square Q. Minus, so it will be minus M omega square Q. Isn't that it? Hello?
Yes, sir. Yes, sir.
Yes, sir.
So, okay. And second Hamiltonian equation, Q dot is equal to del H by del P. So, if you take here derivative with respect to P, this term will be 0, Q term will be 0, and this term will be 2P, 2P, 2 cancel, P by M.
P by M.
P by M. Now, for equation of motion in general law, Newton's law, force is equal to mass into acceleration. Acceleration means x double dot or q double dot. So, for equation of motion, we need double dot. Acceleration, q double. So, q double dot is how much? If q dot is equal to p by m, q double dot will be m is constant, so it will be p dot by m. But p dot is equal to minus m omega square q. So it will be minus m omega square q by m, m cancel. So it will be minus omega square q. Taking this to left hand side, we found q double dot plus omega square q is equal to 0. This is the equation of motion for a simple harmonic oscillator.
Generalized signal.
And this is the equation for any simple harmonic motion. You know that. For any body executing simple harmonic motion, you write x dot plus omega square x is equal to 0. The frequency of oscillation, angular frequency of oscillation. Okay. For simple harmonic oscillator, we got the same kind of equation. Notice that the system is not cyclic. Here it contains Q. Lagrangian Hamiltonian contains Q. Okay. With the original variable. And next we attempt to find a canonical transformation from small qp to capital QP such that capital Q is cyclic, which means that capital P will be constant of motion. Okay. Since Hamiltonian is some sum of squares, you see here Hamiltonian is square P square by 2m Q square half m omega square. It comes as a constant E. For conservative system, Hamilton is a constant, but we see that it will come like P square by 2m Q square. When we add two squares, it becomes a constant. When it is possible? Hello? Okay. Q is a function, time dependent, vary with time. Okay, P is also vary with time. When you square their magnitude and add, we got a constant. When it is possible? Which mathematical function, when we add the squares, it becomes a constant? Any idea? If we add two squares, it becomes a constant or one, let's say. Anything?
Trigonometry function, sir.
Yes, we can use trigonometric functions. Okay, because sine square t plus cos square t is equal to 1. Isn't it? So if q like sine and cos, then will be 1. Okay. From this idea, we know it will be a trigonometric function. So in order to do so, let us consider a transformation. So we let assume it is a trigonometric function q in terms of new coordinate. It may be some function of p by m omega and sine q. omega mass, omega is angular frequency, it is trigonometric function. Similarly, P is equal to Fp cos q. So that if I put here r square, I get it p square by 2m. So it will be f square p by 2m means 2m square omega. But here p square. Okay, I write here. This is p. So what is p square by 2m? Is
S
how much?
square of cos square theta by 2.
P is
S square cos square theta by
square
2.
or f square p by 2m into cos
Cos
square
square
q.
theta.
Okay.
Cos square theta.
Then our potential is half m omega square q square. Half m omega square q square. Here we need that this term is such that it contains same amplitude, that is f square p by 2m into sine square q. If it will be f square p by 2m sine square q, then we add them in capital P, function of capital P, f square p by 2m plus sine square q. Then we add these two taking common, and cos square q plus sine square q will be 1. F square by 2 common. So how it becomes f square 2, but q is, so you have to take q as this one, fp by omega. If it is fp by m omega, q square will be f square p. Okay, and if m omega is m square omega square in the denominator, so if m square m omega square in the denominator, then the omega square cancel, 1m cancel, so it will be 1 by 2m. Clear? So for satisfying this Hamiltonian, we can take q is this and p is this. Isn't it? Hello?
Yes, sir.
Huh. So now p by q, if I divide p by q, I found it will be m, if p cancel, m omega go to the up, and it will be m omega cos q by sin q cot q, m omega cot q, or p is equal to m omega q small q cot capital Q. Again, for the function to be canonical, it must satisfy the partial derivative relations. If it is a canonical transformation, then small p, in terms of generating function, what we know, there are 4 kind of generating functions. Or it will satisfy the small p capital V means if generating function contains small q and capital Q, then we calculate small p and capital V, which is f1. Okay, when we have f1, first function is a function of small q capital Q. f2 function of small q capital P. Isn't it? So by using the formula, small p is del f1 by del q and capital P is equal minus del f by del q1. So this is p. So del f1 by del q is equal to m omega q cot q. So what is the value of f1? What is the value of f1?
PQ plus PQ plus a constant.
Hello?
PQ plus a constant.
M. Now you take integration, isn't it? If you take integration of
Yes,
this
sir.
term, now what do you get?
PQ plus a constant.
No, P. T. Now we have given del f1 by del q is equal to m omega q cot q. Okay. So what is f1? f1 is equal to integration. Is it?
MQ Q square cot theta. Yes, sir.
Q, sorry, q cot q. So integration will be, q integration is q square by 2. So it will be m omega or half
Omega Q square
m
by 2
omega
cot
q
theta.
uh, Q square cot capital Q. Okay, clear? So this is your generating function. We calculate f is equal to a half m omega square cot Q. Then what is capital P by formula? Minus del F1 by del Q. If derivative of this cot Q, other things are constant. Minus half of Q, derivative is cos square Q. Cot Q is minus cos square Q. Minus minus plus, so it will be cos square Q. That means 2 Q square will be how much? 2p by a omega in by cos square Q, 1 by cos square Q, sin square Q. 2p by m omega sin square Q. So Q is equal to 2p by m omega. It's root over Q will be root over into sin Q, and p small p, which is m omega Q cot Q, it will be in place of Q writing this. We found m omega 2p by m sin Q, or 2p m omega root over cos Q. Are you getting my point?
Yes,
Hello?
sir. Yes, sir. Yes, sir.
Oh,
Right.
okay. Since we have explicitly
Sir, here we converted
here,
Sir, here we converted Cartesian coordinate to polar.
not polar. The example is Cartesian to polar. Here we one set to other. One set is small qp, another is capital QP. The
Capital Q.
canonical
But capital
transformation.
Q. Okay.
So here we convert, you see, our small q is a function of capital Q and capital P, and our small p is a function of capital Q and capital P. Okay, our aim is that transform from small qp to capital QP. Since we have explicitly calculated the transformation Q to P using appropriate generating function, and they are canonical, then the now new Hamiltonian K becomes, we know K is equal to H. H means half P square by 2m plus half K Q square, or half m omega square Q square. Okay, K is equal to H. So if you put the value of Q in terms of capital Q, capital P, small p in terms of capital Q, find this. Oh, P square Q square. So adding cos square Q, we found half 2p omega, or 2 half cancel p omega. So our new K or H, or H is also energy. So we found our energy will be conserved quantity equal to P capital P into omega. So H is a time independent quantity, or H is K. So here we can say capital P is nothing but E by omega, energy. So new momentum is energy. It is scale value of total energy. Now what is P dot? Since P is a constant, energy by omega, so P dot will be 0, but P dot by definition minus del K by del Q. Okay, so P is a constant, is E by omega, but P dot is 0, means del K by del Q is 0. Now again, Q is cyclic and P is a constant of motion, we know that. Q dot by formula, Q dot is equal to del K by del P. Our case, small q dot is equal to del H by del P. So here for capital Q, Q dot is equal to del K by del P. In place of K, you write omega P. So we found only omega. So Q dot is equal to omega. That means Q is equal to integration of omega dt, which is equal to omega t plus phi. Phi is a constant and depend on initial conditions. Putting this value of capital Q, omega t plus phi, and capital P E by omega, we write small q is equal to 2 p by omega, becomes 2 e by m omega square sin omega t plus phi, and p becomes 2 m e root over cos omega t plus phi. This is the required equation for simple harmonic oscillator. Okay, clear?
Yeah.
Yes, sir. Yes, sir.
You can derive this. Yes. Okay, these are some plots. If you plot small p versus t and capital P versus t, you already know the capital P is a constant. So plot is look like this, E by omega, and the small p can value like this for simple harmonic motion. Small q for simple harmonic motion value like this. But here capital Q varies like this according to our equation capital Q is equal to omega t plus pi. This term is pi, so it becomes omega t plus pi. Then if you use the phase space diagram, if you plot PQ for simple harmonic oscillator, it will be a ellipse having this axis 2me root 2 over this is 2e by mm square. So area is equal to pi into a into v, pi into this into this. Okay. But if you plot in PQ, since Q is cyclic and phi is a constant, so plot is like this. Okay. The next is application particle in a gravitational field. Okay. So consider a particle of mass m is moving in a uniform gravitational field having acceleration due to gravity g. The one-dimensional Hamiltonian for such a system can be written as kinetic energy plus potential energy and kinetic energy p square by 2m potential by mgy. Or here we take coordinate y as q, so mgq. So if 1 by 2m taken common, it will be p square plus 2m square gq. Where q is the height or altitude of the ground. Gravitational field falling, what is falling from this point? So this height distance is q. Let us now consider a generating function. In harmonic oscillator case, we actually observing the equation of motion, then we set the generating function f. But any other problem or in the procedure of canonical transformation, you have to set a generating function. Here we set the generating function as fqq. It will actually verify. First check taking different generating function, then which one is correct, we found that one. F1 qq will be minus q small q minus qq by 6n square g. But from this equation we can found small p is equal to del f1 by del q and capital P is equal to minus del f1 by del q. Del f1 by del q is equal to minus capital Q, so small p is equal to minus capital Q, and capital P is equal to, if take derivative with respect to capital Q, we found capital P is equal to q plus capital Q square by 2mg. So here you can write small q is equal to how much? P minus this minus capital Q square by 2mg. The small p is minus q, small q is equal to minus q square by 2m square g. Now, like previous case, we calculate the Hamiltonian in new set, that is k, which is equal to 1 by 2m p square by p square plus 2m square gq. Put the value of small p and small q here. P square means q square, small q means p minus q square 2m square whole. Okay, q square 2m square, this is whole square. Q only q, okay. P square is whole square, is only q. So this one. So if you simplify this is q, first term is q square by 2m, second term is here 2m cancel 1m mgp, and third one is 2m square cancel, so q g cancel minus q square by this 2m, but plus q square 2m minus 2m cancel will be only mg capital P. Okay. And the new Hamiltonian is cyclic in Q because Q is absent, it is only mg capital P. That means P dot is minus del K Q is 0. So P is a constant of motion, which is P0. The equation of motion for Q can be written as Q from formula del H by del P. Q dot is equal to del H by del P. We write, so in capital coordinate it will be del K by del P. We have small q dot is equal to del H by del P. When we transfer into capital coordinate, small q goes to capital Q, small p goes to capital P, and h goes to k. So capital Q dot will del K by del P. If you take derivative, k is mg p, so del P means it will be mg. So q dot means dq by dt. So q is equal to mg dt or mgt plus q0. q0 and p0 are constant and they are initial values of the new variables. Now using the equation of motion obtained by the new canonical variables in original variable as given in equation 4, we get qp. Okay. So in small qp becomes, now we found capital Q here, small p equal to minus mgt here, mgt plus q0 is equal to capital Q, but small p is equal to minus capital Q. That means minus q0 mgt, and q is equal to, we have the formula, p minus capital Q square by 2m square g. Putting capital P Q value, we found capital P Q means this square. We got this value. Above the solutions for the free fall case. On the initial moment here, the initial momentum is q0 because, and maximum height is p0. Okay, this is the equation of motion for body falling freely. Okay, this is clear.
Yes, sir.
Hello. Okay. On next session is your bilinear invariant. First, to discuss the condition for a transformation to be canonical. We already discussed this in when we are discussing about canonical transformation and Poisson bracket. And one condition is Poisson bracket should be 1. Another condition is a perfect differential. Condition is capital Pj dqj minus Pj dqj. This term is a perfect differential. Okay. And an exact differential. This is the condition. We already discussed it. So we know that the transformation is canonical from two equations. It is for old coordinate, it is for new coordinate. Okay. So old coordinate p take q minus h, it is minus k is equal to df by dt. F is actually basically generating function. And from this we found the relations, and since our k is equal to h plus df by dt, if f does not contain time, then it will be h. So basic condition is Pj Qj dot minus sum dot Pj capital Pj Qj dot df by dt. If we multiply dt in each term, dqj by dt into it is equal to dqj, d capital Qj by dt into dt is equal to d capital Qj and df. But this is the condition. So if this is a exact differential, then we call it a transformation is canonical. There are some example. We also discussed few example and another example. So that this transformation is canonical, you have to prove that PdQ minus QD, okay, small p d small q is a exact differential. If you write, okay, so means it is differentiable. Now calculate q, capital Q is given, then you can calculate dq capital small. Okay, if you convert 1 to small q, then it will be already cancelled with. First, we have to take into one coordinate, either to all capital or all small. Okay. And in general case, since capital QP is given, dq is very easy to calculate capital dq. So, and capital P is written here. So, dq into p is easily calculated, which is found in terms of small q and small p. Okay. So, you put that and see in some quantity cancel, and we got the exact differential. Q is given. Q is how much? 2 small q root over e to the alpha cos p. What is dq? There are two variables, q and p. So there are two terms. In terms of q, it is root 2 remain the q to the root q. Derivative of root q is half q to the power minus half. Isn't it? Into dq. Other things constant e to the alpha cos p dq. Plus in terms of p, cos p means sorry minus cos p derivative is minus sin p, so remains other things same, 2q root 2 over e to the power alpha sin p dp. We have two terms here. Okay, these two terms. Huh? So now substitute this value here. P dq minus P dq. Okay, you see this quantity 2 root 2 cancel. It will be 2 by q root over e to the power a. One is a, one is minus a. A cos p dq. Okay. It is 2p e to the power minus a cos p. But this quantity is nothing but yes, if you see p dq. Okay, we cancel. So this is all sin p cos p dp minus dq sin p p dq. So if you taking dq common, dq is here, we write sin p cos p minus p and dp as 2q sin square p dp, which is equal to sin p cos p. You know 2 sin theta cos theta is equal to sin 2 theta. Or I can write it half sin 2p minus p into dq equal minus 2q sin square p dp. So it is the derivative of this term half q sin 2p. If the derivative half q sin 2p minus q. Because if take the derivative of q, it will be p, and if take q, it will be half sin 2p. Similarly, this term you take derivative del by del p of half q sin square sin 2p minus pq. With respect to p, it will be sin. Okay, sin
U
2p
cos
means
P.
2 sin p cos p, and derivative is this. So we found take this quantity as f. So del f by del q into dq, del f by del p dp means it df. It is an exact differential function. So it is a transformation is canonical. Similarly, you can prove this case given. This time problem is coming in your examination. Also prove this one. Taking PD. Keep the small pq as it is and convert capital P dq to small p small q. If it's given in terms of pq, if left hand side is small p, then you can use capital PQ as constant. Okay. If question is this, not this, then you take capital P dq as it is and calculate small dq, then multiply it with small p, then calculate. Okay. Next thing is 1f2 identity transformation. If their generating function is minus round of qj pj, then according to formula, small pj is equal to del f2 by del qj, del f by del qj. Uh, so del f by del qj means it will be capital pj because qj pj, it take derivative with respect to qj, it will be capital pj. Similarly, our capital qj is equal to del f by del capital pj. If you take derivative with respect to capital pj, we found only small qj. So if you come, you see, so here small pj goes to capital Pj and capital Qj goes to small qj. What it means? So we transform Qj to capital Qj. Qj goes to Qj, Pj is equal to Pj. This transformation is known as identity transformation because q small q in whole coordinate is exactly equal to capital Q in new coordinate. Small p in whole coordinate is exactly equal to capital P in new coordinate. So that is equal identical transformation, and so generating function for identical transformation is f2. F2 means f2 is a function of small q capital P. For identical transformation, and we generally we use this f for generating function f2 and k is equal to h. Okay. Then is bilinear invariant conditions. The condition is that if a transformation set capital Qj Pj set is canonical, then the bilinear form. Bilinear form means what is our condition where Pj dQj minus Qj dPj is general condition. Here we in place of Pj delta Pj and first Qj delta Qj. Delta Pj dQj minus delta Qj del Pj. This form is known as bilinear form. Summed over J delta Pj dQj minus delta Qj dPj remains invariant. The condition if a transformation set is canonical, then this remains invariant and this bilinear form. And this statement means it remains invariant means this is the same as old coordinate is equal to same new coordinate. So if we replace small pj by capital Qj, small qj by capital Qj, then we got the same result. So it is invariant. But we know that from canonical transformation, small qj dot del h by del pj, pj dot del h minus del h del qj. Okay, from this here you can say dqj by dt. So dqj will be del h by del pj into dt, and dpj is equal to minus del h by del qj into dt. Okay, so similarly, capital comparing this, d capital Qj is equal to del h by del Pj dt because h is equal to k same, and capital Pj dot is equal to minus del h by del Qj into dt. So if I take one side, this equal to how much? 0, and this equal to means plus is equal to 0, is not it? So if I multiply anything, this is summed over delta Pj, so it will be into 0, it will be 0 minus delta Qj into this term, it will be 0. So final result will be 0. Okay. Variation of delta arbitrary, but since that delta Qj and delta Pj are arbitrary, and substituting the coordinate delta h by delta Pj is equal to how much? Qj dot. Okay. This is equal to 0, clear? We put this because this term is 0, something at 0 is 0. Okay, something at 0, 0 minus 0 is equal to 0. I write this. Now, if we
Sir,
did,
so what exactly is the difference between delta Qj and dq?
only small. Delta Qj means it is very small. Delta variation.
Mhm. And the
Small
dq
variation.
and dq also small, sir.
Small, but delta is very small.
Okay,
You use for very small variation, very small sense.
so
D
it is
is
small.
differently general derivative. D is your general derivative, but delta is very small variation.
Okay, sir. Okay.
And nearly constant. Delta B is nearly 0, epsilon, very small. Okay. It is
Understood.
actually, you take a dqj division, nothing sense. But our aim is to show the coefficient equate to 0 and then we get the condition. For that reason, we take a different one. One is d, one is delta. Okay. You can
Yes.
take another symbol in place of delta,
Okay, sir.
epsilon. But since it's derivative, general delta is equal small. Okay, now see here coefficient of uh, dqj and dt. What are the coefficient of dt? Right here, coefficient of dt del h by del pj and delta pj minus, both are minus. Here minus minus, take minus common plus, and keep other one as is. Other one is this one minus this one. Okay, delta pj dqj, delta qj dpj. Okay, four terms come. But what is this? Since h is a function of qp, so delta s is equal to del h by del qj into dqj, delta h by del pj dpj. D in place of d you write delta, so it is nothing but delta h. This bracketed quantity delta h, because d if f is a function of x y z, then what is df? Df is equal to how much? Whatever del x by del f by del x
Del F by
into
del x, that
dx
df. Del F
plus
by
del f by
del
del
y.
y. into dy for del F by del z into dz. Similarly, here h is a function of qp. So delta h is equal to del h by del qj delta qj plus del h by del pj delta pj. Okay, so it is nothing but a delta h. So this delta dt is equal to 0. But similarly, for we obtain for new coordinate k when k is equal to h, delta of capital pj d of capital qj minus this equation, all small will replace by capital and h will replace by k. Since k is equal to h, it can keep same as it is, or delta as it is equal to 0. Now equate these two. If I take this will be right hand side is same, right? This is same means these two are same. Delta pz equal to capital. This is actually a bilinear invariant condition. Okay. Hello? Are you getting my
Yes,
point or
sir.
not?
Yes, sir.
Sir, what is its physical significance? And so when it will be invariant?
All are canonical transformation is canonical. Okay, we have to prove because this type of question is coming in examination. These are just like problems. So that it is canonical or not. If once it is canonical, then we can use all type of Hamiltonian formulation there. So here we are only checking the transformation is canonical or not. What are the possible conditions? How they are related. Okay.
Okay, sir.
Actually, here Lagrangian formulation and Hamiltonian formulation, they're not directly related to any experimental thing. It is a how to study it. It is a theoretical approach. Lagrangian
They are
formulation, Hamiltonian
mathematical only.
formulation.
Uh,
Theoretical approach to study the system. But we can predict by theory. Studying this theory, we predict the result. Okay, only one. It is a theoretical approach. Whether you are using Lagrangian formulation or Hamiltonian formulation. Okay. But direct you got Newtonian equation, force, mass, acceleration, you calculate all these things directly there. But for a system, okay, these are the formulations. To show that transformation, there is a problem. You can also check the canonical or not by taking the differentiation and obeying the formula. This. Okay. Then another thing is infinitesimal contact transformation. The infinitesimal is very small. No? These are the transformation in which old and new component differ only slightly. So infinitesimal is very small. They differ very slightly. We have shown in example 4, you see that the function f2 generates the identity transformation. We already see that f2 if f2 generates the identity transformation, that is capital Qj over small qj and capital Pj small pj. Here we are interested to those transformation Qj and Pj which are slightly differ. Capital Qj is Qj plus small thing. Capital Pj Pj plus small thing. For that, we know exactly identical comes from this. For slight change, we add a very small quantity and a function of Qj, capital Pj. Okay, this gives you identity. If f is this one, by taking our formula, we calculate small qj equal capital Qj, small pj equal capital Qj. But now we want to get a new capital Qj or new capital Qj, which is very small different from small qj and small pj. For that, we take f as this old one, which give identity plus a very small quantity epsilon into a function of qj pj. Okay. So since g is an arbitrary function, so new variables will now be given in the following equations. So from this f, using our formula, capital Qj is equal to del f by del Pj, we found it will be Qj plus epsilon, Pj is a function of Qj Pj, epsilon del g by del Pj. Similarly, small pj, because your variables are small qj and capital Pj. Two unknowns are small pj and capital Qj. Small pj is equal to del f by del qj, which is equal to qj pj plus epsilon del g by del qj. Okay. Let's say it's very small. The deviation is very small. That is capital Qj minus small qj is very small. Delta qj, which must be given Why origin must be equal to this one? Because here capital Qj, here small qj. So capital Qj minus small qj is equal to this quantity. Capital Pj minus small pj is minus, is negative this quantity. Because the differentiation is very small, infinite small, we can replace capital Pj and small pj in the function of g. Here g is a function of small qj, capital Pj. Since very infinite small change in capital Qj is equal to small qj plus very small quantity. Capital Pj is equal to small pj plus very small quantity. So we can take in both are equal. When we writing function, I can take small qj, and small capital Pj, small pj. So that we g comes in one coordinates. Replacing this capital Pj by small pj, add g is a function of qj and pj. So our delta qj becomes epsilon del g small qj pj function by delta, and pj is equal to small pj del pj, and delta pj becomes minus epsilon del qj pj by del qj. These are infinitesimal transformation. In this case of infinitesimal contact transformation, it is constant transfer the description to the function g instead of f, which is originally taken as the generative function. Thus, g is new generative function or generator of infinitesimal contact transformation. With this change of description equation, I can start to giving the infinitesimal changes conjugate to variable which is generated by the arbitrary function g. We consider a particular example. Let's say epsilon is equal to dt. If you put epsilon dt and g is h, taking g is h, the Hamiltonian generative function becomes delta qj. Epsilon in place of epsilon by dt, and plus dg by dpj into g at del h by del pj, which is nothing but del h by del pj qj dot dt into qj dot means dqj by dt. So it will be dqj. Similarly, delta pj is equal to dpj. This change in the conjugate variables actually occur in the system in the course of its motion. That is the represent an infinitesimal change in coordinates with the system moves for a time dt. So it is actually conversion from infinitesimal transformation to normal transformation. Okay. Okay. Or any problem?
No
Hello?
problem, sir. Okay, sir.
Okay. Then we go to our next session. The last session is uh, symplectic approach and Liouville's theorem in terms of Poisson bracket. Okay. Okay. The symplectic approach to canonical transformation. Actually, it is another method. The symplectic means we have here express everything in terms of matrix. Oh, yeah, this is known as symplectic formulation of Hamilton's equation. You have to write in terms of matrix. Okay. We know from our canonical transformation, restricted means here lambda is equal to 1. Extended means lambda is not equal to 1. Canonical transformation, we know capital Qi is a function of small qp and capital Pi is a small function of small qp. And the time derivative of Qi dot equal to how much? If Qi is a function of qp, just like f is a function of xy, since capital Q is a function
0.
of p, and 0, we have expand it. What is q dot? dq by dt. Okay, it will be how much? Del
0, sir.
q by, not I am calculating 0. Q is a function of qp, just like your f is a function of xyz. So what is df by dt? Tell me. df by dt is equal to how much? You have written many times. So it will be del f by del x
De-
into dx by dt plus
yes,
del
sir.
f
Yes,
by
sir.
del y into dy by dt. Is not it?
Yes, sir.
Plus del f by del z into dz by dt. Similarly here it is only function of small q and small p. So qi dot will be del qi by del small q into q dot means this is x dot, this is your y dot, divided by z dot. So qj dot means dqj by dt, qj dot del q by del pi pj dot del okay, only two coordinates qp. So qj dot means what, from Hamilton's equation of motion we know qj dot is equal to del s by del pj, and pj dot is equal to minus del s by del qj. So it is just like del qi by del qj into del s by del pj minus del k by del pj del s by del pj. So it is nothing but
Poison.
Poisson bracket of qi
And H.
h. Okay. Okay. On the other hand, the inverse of this transformation, if small q is a capital Q is a function of small qp, capital P is a function of small qp. If we reverse it, small q is a function of capital qp, small p is a function of capital qp. In that case, if I write so qp and from the partial differential derivative, but del s by del pi, capital H is a function of, if it is a function of qp then will be del s by del p. H is a function of, that's a small qp t, but regular t. So its derivative will be del s by del p into del small p by del capital P, del s by del q, del q by del capital P, like this. Okay, if H is a function of qp, del s by del p have this formula, but qy dot is equal to del s by del pi. We know that when we concluded this, comparing these two. Whenever we are general, we know that qi dot is equal to del h by del pi. This one. Uh, so that is, the transformation is canonical only if, so the left hand side are same. For canonical transformation, qi dot is equal to del h by del pi. For transformation is canonical, these two left hand should be equal. That means right hand side should be equal. Okay. Okay, I am saying. Okay. Now, if the equation is canonical, then Hamilton's form remains invariant. Qi dot or qj dot, what you write, it must be equal to del s by del capital Pi. Okay. That means these two are same. Since left hand side same, right hand side must be equal. These two term will be equal to this. Then what is the condition? Del s by del pj here multiplied with del pj by del capital Pj. This must be equal to del q I by del small qj. And here del s by del qj is multiplied with del qj by del pj, here minus this. So this term must be equal to this term. Okay. Only these two are true. These two are equal with each other. Then we can write that it is a transformation canonical. That is q dot is equal to del s by del pi. Are you getting my point?
Yes,
Hello.
sir.
Yes,
Yes,
sir.
sir.
Canonical means. Okay. So actually we write these conditions here. Yeah. So del capital Pi del Qj Qp is equal to del Pj by del Qi. Inverse of this. We write inverse of this like this too. Direct conditions. Okay. Known as direct conditions. And the algebraic manipulation that let 9448 we perform the compact and alien manner. We make use of the symplectic notation for the Hamiltonian formulation introduced above. Okay. Symplectic notation when we have to want to represent in terms of matrix. that if eta is a column matrix with 2n elements qi and pi, then the Hamiltonian equation can be written as the form eta dot is equal to j del s by del eta. You can easily derive this. Okay, not necessary here. So eta dot is equal to j into del s by del eta, where eta is a column matrix. Next aim is to convert it to a matrix form. So if we take eta is a column matrix, it has 2n elements q1 to qn and small p1 to pn. Then Hamiltonian equation can be written as eta dot j into del by del eta, where j is the antisymmetric matrix. Okay. That was discussed in the previous section, it was derived. Similar, the new set of coordinates q pi and have 2n elements column matrix zeta, which is a function of eta. Okay, go to the matrix exact form. And the matrix notation zeta dot is equal to m into eta dot, where mij is equal to this. Okay, it is only written. A variation of Hamiltonian with respect to a coordinate eta can be written as, if h is a function of zeta y, its chain rule, del s by del zeta is equal to del zeta by del eta. And using these equations, okay, del s by del eta is equal to m del s by del eta, or equating this zeta dot, but zeta dot is equal to mj this. Okay, mj del s by del eta. If del s by del eta is this, so zeta dot to mj into this, mj into this. Okay, so zeta dot is equal to a quantity. Comparing this, we found with this first definition, mj m is equal to m. It is a transformation, matrix transformation. Okay, you know, if a quantity identity matrix A I similar transformation, we call it tilde equal to I. Similarity transformation in matrix is known as, so actually the condition of similarity transformation. So you can get here lambda j is the eigenvalue if mj. Okay, this is not necessary the matrix thing. Finally, we got this is the eta. We take it as a, if it two-dimensional, for example, let's say only is a function of q1, q2 and p1, p2. Then eta is a function of small coordinate and zeta is a function of capital coordinate. Okay, so this capital coordinate q1 derivative zeta dot is equal to m eta dot, or it can be written as q1 dot q2 dot p1 dot p2 dot m into this quantity, and the M matrix must be like this. So that we found this result, that q1 dot p2 dot minus p1 dot minus q2 dot. With difference, okay. Is it just like transition when old coordinate and new coordinate are related to this equation, this transformation, and this is the transformation matrix. If you multiply like this, we got this. You have to remember this matrix. It is another kind of matrix, 0, 0, 1 actually. 0. Okay, if you multiply with this, you result got it. It was only written matrix. You have to remember this form of matrix 1 0 0 0 0 0 1 so that when you multiply the result you can easily get multiplying this. But you have to remember capital Q1, Q2, P and P2 is equal to this matrix into this. It is no simpler way. Okay. Now come to this infinitesimal canonical transformation. Let's say capital Qi is equal to small qi into delta Qi, very small, and capital Pi is small p and delta Pi. And so in this way we can write our change zeta is equal to eta plus delta eta. But you already discussed if you have two for identity transformation to infinitesimal change. This is your identity transformation for F2 and we add for infinitesimal change epsilon g. And so let's discuss that capital small pj is equal to capital V epsilon delta small pj. We already discussed this and this transformation. And comparing this, we can write capital P small q. We already got these equations. Okay. Infinitesimal transformation. Generating function of the infinitesimal transformation. And then transform can be written as delta qj is equal to epsilon del g by del pg. By comparing this, we can write also delta eta is equal to epsilon j by del g by del eta. And this is an extension of infinitesimal transformation. We already derived these equations. Okay. From this, we can also get the finite. If we add slightly infinitesimal, we got a finite value. Okay. Our aim is everywhere identity 1 plus how we construct other elements. We add small epsilon. Okay. But we want to 2. We get result 2. How it is possible? Many times if you suppose epsilon is 0.0001. So you have to add epsilon many times. By repeating this operation, we can somehow get the value of 2. That is the thing. How get a finite one from infinitesimal relations? Infinitesimal version. Okay. Example is infinite canonical transformation. Let's delta t0 is delta 0 plus delta t. So a matrix actually identity plus a small variation of delta L. Right, instead of D we got this one and this is same. And mg similarity transformation we found this mgm is equal to j. This is similarity transformation proof. And this is simplicity condition holds for any infinite canonical transformation by the chain of reasoning. Okay. These are the four conditions. The identity transformation is canonical, either a symplectic or generator formalism can be used to prove that canonical transformation have the four properties. Canonical transformation of four properties. First property is the identity transformation canonical. If a transformation is canonical, so its inverse is canonical. Two successive canonical transformations define a transformation that is also canonical, and the product operation is associative. These are the four properties of canonical transformation. Identity transformation is Qj to capital Qj, Pj to capital Pj. This is a canonical transformation. If a transformation is canonical, then its inverse transformation is canonical, and successive canonical transformation means resultant is also a canonical transformation, and product is associative. A into B plus C. Okay. Or A into B C is equal to B into AC. Okay, C. Then come to the this section is basically symplectic means you have to write in terms of matrix and how we get from infinitesimal to a regular one. Repeating operations we get the regular one. Okay, but it is actually analysis is quite difficult to understand it. Okay. Hello? Any doubt? Actually, the analysis you have to learn more if you want to exact analysis, which actually not in your syllabus.
Sir, in syllabus only 3 pages are there in symplectic approach.
Yes.
It has been so compact.
But, Simplicity. So in general, our MS syllabus it is not in our course. Symplectic approach is not taught. It is just meaning is one way to another way to represent terms of matrix. It is actually no use. Main reason is by repeating infinitesimal transformation, we get a finite transformation. It's the main thing of this section. Okay. Uh, but general syllabus is not symplectic approach. Why it is written in your syllabus? I can understand. Okay. Uh, now come to the little easy part. The equation of motion and infinite circumference transform the conservation theorems in the Poisson bracket formulation. Okay. Uh, as you know, if u is a function of qpt, then du by dt is equal to del u by del q into dq by dt plus del u by del p into dq by dt plus del u by del t into dt by dt 1. Okay, like f is a function of x y z and df by dt is del f by del x into dx by dt or del f by del y into dy by dt or del f by del z into dz by dt. Okay, so del u by del q into dq by dt is qi dot, del u by del p into d by dot pi dot, and del u by del 2 into 1. So del u by del qi and qi dot is equal to del h by del pi. We know that from Hamilton's equation, and pi dot is equal to minus del h by del qi. Okay, or del u by del t. That means du by dt is equal to these two terms, is basically Poisson bracket of uh plus del u by dt. This is the equation of motion. So du by dt is this. Of if u does not explicitly contain time, then this term is 0. Another thing, if u is a conserved quantity, this term is 0. We have two conclusions. If u is conserved means capital du by dt is equal to 0. Then we can this is equal to 0. You can calculate this. But if u does not contain time, then this is 0. Du by dt is equal to uh. Suppose some u is given, if it is does not function of time, then you can calculate du by dt as taking only Poisson bracket of u and h. Or sometimes even u is a constant of motion, then if u is a constant of motion, you can write del u by del t partial derivative. This term is 0 if constant of motion is equal to minus uh. Okay, uh you go to this side, it becomes minus. In terms of simplicity notation also, you can write this equation du by dt is del u by del eta into eta dot plus du by dt. These two terms, you can write also eta qp in place of qp. So again eta dot is equal to j to del h by del eta. Okay. What you can write this? Okay. In Hamilton's equation motion, we know that Hamilton, we write Hamilton's equation motion in terms of Poisson bracket. Hamilton equation motion is ui dot is equal to del s by del pi. Is not it? How to write in terms of Poisson bracket? See here, ui dot del h by del pi. But here, dot means what? dq by dt. dqi by dt. In place of u, we have qi. Let's say here in place of u, okay, leaving this one, or this one. Here in place of u, we have qi. Then dqi by dt is equal to how much? Here I write in place of u, qi, isn't it? Here I write
Yes,
qi
sir.
in place of u. So this is the equation. So dqi by dt or qi dot is equal to Poisson bracket of qih into dqi by dt. Q and T are independent coordinate. Q1 to Qn, P1 to Pn, then T. They are independent. So dq by dt is how much? If Q and T are independent, this will be equal to independent means does not Q does not contain T. Then del Q by del T is equal to
0.
0. And there is a difference between total. What is the difference between total derivative and partial derivative?
Means we will not consider other variable. The other variables will be constant.
Yes. For partial derivative, other variables are constant. We don't explicitly, we directly explicit form we take. Suppose dx by dt. X may be a function of t, but here dx by dt 0. But if here x is a function of t, we cannot say dx by dt is equal to 0. So here this is 0, so qi dot is equal to basically qi by h. Similarly, if I take pi dot is equal to Poisson bracket of pi h. These are the equation. Okay. Hamilton equation and symptom notation. Basically, symptom key means it qi py is equal to eta. In place of q and p, I take a common thing eta. And simplistic qi and pi we write eta. So eta dot is equal to Poisson bracket of eta h. Okay, but eta dot actually j del h by del eta, the also eta is equal to this. Property and dh by dt and del h by del t. So what is value? If this is equal to thing, you know it. Let write here h. Let u is equal to h. Then it will become dh by dt. This u becomes h. This becomes h. Okay. So what is the value of h Poisson bracket?
0.
0. Okay. Not only h, any Poisson bracket of x is
Anything
0.
same
Not only x and function of x. Poisson bracket is also 0. If
Yes, sir.
second term is the only function of x, then Poisson bracket 0. So 0. So that means dh by dt is equal to del h by del t. Now the generalized equation of motion is canonical invariant. Canonical invariant is whether the canonical value qq to express the function. Okay. So u is a constant of motion. What I told you. Suppose here u is a constant of motion. U is a constant of motion means what? U is constant. So which
du
term
by
is 0?
dt is 0.
U by dt 0.
Yes, sir.
So what is the del u by del t value? If it is 0, then I can write del u by del t is equal to minus of Poisson bracket UH, which is equal to minus Poisson bracket of HU, because Poisson bracket of XY is equal to minus of Poisson bracket YX. So du by dt is equal to HU. Okay, these are the things. Hamiltonian vanish, they will HU 0. Then if you calculate u v here, Poisson bracket with h 0. Suppose u v are two constant of motion, and then w is Jacobi identity is called h u v is equal to 0. If u v are constant of motion, then Poisson bracket of u v with h is equal to 0. The Poisson bracket of any two constant of motion is also a constant of motion, which is also known as Poisson's theorem. Another is Jacobi, it means UVW, Poisson bracket in order. U, Poisson bracket of VW. I think we have already discussed in past Poisson bracket class. Plus Poisson bracket of V, WU plus Poisson bracket of W, UV is equal to 0. This is known as a Jacobi identity. Okay. Now, if the zeta is equal to eta plus del eta, then del eta is basically epsilon time your variation j into del j del eta, and eta u. We take Poisson bracket, it will be j del u by del eta, which we see previously. Next is an example. Suppose del u we take a change in UV minus UA. UV means eta plus del eta, it is eta. Then del u will be equal to, this is the like differentiation on limiting case, del u by del eta into delta eta. That is a Newton only epsilon symbol, and okay. Not other thing. Leave this. Okay. Already discussed this. Then come to the last one, which is your this is general thing. Liouville's theorem in terms of Poisson bracket. Actually, according to Liouville's theorem, phase space density d rho is a conserved quantity, del rho by del t is equal to 0. So, in terms of Poisson bracket, we know the derivative of any quantity is equal to du by dt is equal to how much? Poisson bracket of u with h plus
du by dt.
del u by del t. So if rho is a constant, so if in place of u, if I rho, del rho by del t is equal to rho h Poisson bracket plus del rho by del t, isn't it? Actually, this
Yes.
define quantity. So if rho is does not contain time explicitly, then del rho by del t 0. So d rho by dt means rho h must be 0. This help you to define or used in your statistical mechanics. Rho h is equal to d rho by dt. In statistical mechanics, we actually use different type of ensemble. Suppose this system has a number of each system, thermodynamic, let's say thermodynamic system we consider, it has some external properties which we can measure: energy, volume, temperature. It is of the whole system. Suppose of the whole body, when we have temperature of the whole body is there. But any system consists of a large number of small things which we call it microstate. This one is macrostate, large one, macrostate, and internal microstate. Microstate, suppose macrostate, you are sitting in a class. Every day you are 10 people. You are sitting in the class and 10, there are 10 seats. So once all seats are filled, each one macrostate comes. But someone comes at 11 a.m., then 12, then 1 p.m., 2 p.m., see 10 people are sitting. Each come macrostate. But when it comes 11 a.m., you see, suppose A is sitting here, B is sitting here. But at 12, suppose B is sitting here, A is sitting here. Similarly, changing their position. Each position is known as a microstate. But macrostate means final room contain 10 people. That is macrostate. Macrostate remains same. But microstate is changing. each macrostate contains a large number of microstates. Large number of microstates, if it has contain large number of microstates, then it has longest probability to stay. Okay, which is not affected by outsider. If you are more, you can adjust yourself. How much you adjust will the longest state. Suppose they are distributed many ways, they stay in a particular state for a long time. If there is no disturbance, internally they exchange their position, everything. If there is no disturbance, they stay for a long time. Okay, so we call it the most probable state in quantum mechanics, and classical mechanics is known as equilibrium state. So equilibrium state has large number of microstates, and a collection of these states. Actually, the time the state is changing, 10, 11, but we use a concept in statistical mechanics where we take all things. Suppose 11 picture, 12, 1 p.m., 2 p.m., 3 p.m., all picture in one frame. Suppose someone, just like in Facebook, you uploaded photograph in January, February, March, but at the end, in December, it comes how your year is. It contains photos of January, February, March, April. Read. Hello?
Yes, sir.
Uh, that. But here the photos are, it is January, it is February. Time evolution, January 1, February, but all time are here in one frame. And statistical mechanics, actually, that is known called ensemble. Ensemble is a collection of microstates of a macrostate at a particular instant of time, whereas a microstate evolve with time. Microstate changes with time. Photo changes with time. This January photo, February photo, March, April photograph. But at a particular time in December, it shows all photos in one frame, which are depend on time. That is known as ensemble is a collection of all microstates of a given macrostate at a particular instant of time. Okay. Why we are using but the ensemble? If you heard what's micro-canonical ensemble, grand canonical ensemble, in your graduation, you heard these words. Actually, the ensemble all are defined through this Liouville's theorem. The phase density is constant for everything. That means d rho by dt is equal to 0. Liouville's theorem we already proved in classical, but here we are discussing in terms of Poisson bracket. So d rho by dt is equal to 0 means d rho by dt is equal to rho x. Rho h Poisson bracket plus del rho by dt. We know Liouville's theorem, this will be 0. This 0 means this is equal to 0 if rho does not contain time explicitly, this is 0. So rho h is equal to 0 because in system study we time we take fixed. It is stationary system, so time independent. Equilibrium system, so time independent. Doesn't depend on time variation. So rho h is equal to 0. Rho h 0 means what is the value of rho? If rho h Poisson bracket is 0, then what will be the rho value? What are the values? Tell one thing. Rho Poisson bracket of rho h is equal to 0. Then rho is equal to how much? Simplest thing is possible when rho is a constant. True. What is the Poisson bracket of a constant with h or constant with x or q?
Yes, sir, it is 0.
0. And that represent your micro-canonical ensemble. If you have the word micro-canonical ensemble. Okay. Another thing is rho may be a function of h. Depending on nature of function, there are many ensembles, but we particularly use for due to physical significance other two kinds. One is canonical. For canonical, this function is e to the power minus h by kt. Is Boltzmann constant, and another is for grand canonical, e to the power minus h by kt plus mu by kt. Okay, these are three things comes type of ensemble comes from the Liouville's theorem. Okay, you written this here. If d is a quantity, we already discussed. Then in, this will be dh by dt plus del d by del t, Poisson bucket term. Okay. What is the hydrodynamics? Finally, I written all these things in description as the two systems. Q and motion of a volume in two-dimensional phase space. If two dimension, there are two coordinate QP, T1 and T2, two time depend initial and final. Flow is going on QP. Okay. So del D by del T 0, what implies del D by del T is how much? This one del S plus D by this 0. Del S plus Poisson bucket del D by del T is 0. Isn't it? That means del D by del minus del S by del T. If it does not contain time explicitly, and ds is equal to 0. This is the condition for Liouville's theorem in terms of Poisson bracket. Okay, I can answer this. Okay, in doubt? It's particularly
sir.
used in statistical mechanics. So use it in statistical mechanics, but your syllabus it is written as Liouville's theorem in terms of Poisson bracket. I'll read this. I have written is well known microcanonical ensemble is d is a constant. Example given if d is a constant, then we call it a microcanonical ensemble.
Sir, a general doubt. If a conservative system is a path independent, then which is path dependent then, so to calculate the potential?
And there are many path dependent quantity. Okay. Here path independent means work done. If you work done, closed path is 0. For a conservative system, work done is path independent. When you go from
The
1 to
friction will
2,
be there.
the work done is same. Work done is path independent.
Okay.
Not
Friction of something, then the displacement will not.
work done is path independent means work done is always work at 2 minus work at 1. So if you do to one in a closed path, work done is 0. Are these one is positive, one is negative, 0.
Fine. Then path dependent, then like
There are many
Patita.
path dependent quantity, heat, other things are path dependent quantity. Uh, okay. Path dependent, and if you change the path, then it will be different.
ठीक है.
Main thing is, if you change the path, then that quantity will be different.
Okay, sir.
And not same for all paths. Okay, that. You see many quantities are different.
Sir, is it, sir, the way Patit told, like it's the work done during the friction, so that will be path dependent?
No, friction means it is non-conservative. So obviously it is not path. It is path dependent.
Okay.
Friction means it is non-conservative. Okay. Energy is no more conservative. Any other doubts? This is your last class, okay? What was I cover important things of the because it is difficult to cover all two syllabuses in one unit in one class, 1 hour. It is very difficult, but I tried to cover most of the things, very important things actually, which are important.
Thank you so much, sir. It was really beneficial because we at
Okay.
least got all the ideas, then we can do some self study. Previously it was very
Yeah.
difficult to imagine also.
Uh,
So thank you, sir. But we'll study afterward. Any doubts will come, then we'll.
yes, yes, yes. You can ask. Okay.
We want a one session just doubt clearing if it is possible. So,
Actual, some part is also not in any MSc course, which is
yes.
actually give you book or reference means. Actually, in what we are teaching in our MSc, only half of your syllabus. If I add to 002 and 006, only half, what's like 70% is in our syllabus. 30% is not our syllabus, but it is in your syllabus.
Sir, would
So,
you provide any PDF notes for the students?
now, for his class, I am sending the notes. What I am teaching, that is a.
Okay, sir.
I am sending the material. This material because in our syllabus, this is not in our syllabus. So I have not made any notes. For that reason, I follow the book for this last class.
So
Okay,
this is from
but
Goldstein book, sir. This is
yeah,
from
yeah.
Goldstein. Okay.
Goldstein book. Other books is also not written. Any book, only Goldstein written this section according to the syllabus. I see 3 4 weeks others they have not written this because it is not generally it is not studied anywhere. But someone made it syllabus. I think he made from Goldstein, so he add this thing. Okay, okay, and
Thank you, sir. Thank you.
Thank you, sir. Thank you so much, sir.
okay,
Sir, sir, would you provide some sample questions if
okay.
possible,
Best
sir?
of luck for your examination. Thank you. No, no, I have no any sample question because it's first time and they only told us to teach. We don't know about the questions who will made or how it is act. Uh, they said that they
No, sir.
will instruct
Means
you. They will instruct you
no, sir.
regarding the questions. They told that. Okay.
No, no, sir. Not means not related to our means IGNO exam. So, a few previous year question of classical mechanics from your university also you can provide. So
Because
it will be
we have
helpful.
done a long
See,
question after main question, otherwise problem type. But in main semester examination, long question. But I think in IGNO, whether any long question will ask or not, I don't clear.
but sir,
They
it's
told
okay.
you,
Means it
uh,
is first time examination. If you will send a few question of your university also, we can at least imagine. Means it will be easy for us to think this kind of questions are there. So, whoever will be making question will have that kind of thinking.
okay, I will send you one question in a group, 1 year question. You can see. Okay, but
Thank you, sir.
Sir,
I'll send you the
sir,
group.
in which group, sir?
Thank
There
you,
is
sir.
any
That
another
will be
group or
great, sir.
Official group, you have made some IGNO official or like this.
okay.
Okay. Shall I leave?
Yes, sir. Thank you, sir.
Okay. Okay.
Okay, sir.
Thank
Thank you,
you
sir.
uh,
Thank you.
and best of luck.
Yes, sir. Thank you,
Thank
sir.
you, sir. Thank you.
If there's some that type of question, that will be very great. Very.
Okay,